When you're looking at a integral such as this one, hopefully integration by parts comes to mind. And that's because a lot of times when you're dealing with natural log, the integration by parts is a good sort of approach. Now what's weird about this is what you let be your u is seemingly, well it is in fact the integrand, and then dx is just dv. But that should be familiar when you first learned to integrate just ln x dx, you knew you use that sort of little strategy. So we'll let u equal the sine of ln times of 8x, ln of 8x. So then du will equal the derivative of the sine, which is the cosine. You remember you rewrite the inside. We're using the chain rule here to find the derivative, times the derivative of the ln, which is 1 over whatever you're taking the ln of, and then times the derivative of the inside, which is the derivative of 8x, is just 8. So those 8's cancel there, and then you'll have a dx. And then your dx, of course, you're just going to let, your dv is just going to be equal to dx, which means that v, if you integrate dx, is just x. So this integrand is going to be 3, and remember we go uv, so that's going to be x times the sine of ln of 8x, so I did vu because it just worked out a little bit cleaner, minus the integral of v du. Now notice when you multiply v, which is x, times du, which is all of this, the x there will cancel, and so that's kind of what you're going for. You're going to get the cosine of ln of 8x and then just the dx, because the 8's had canceled before and the x's cancel when you multiply there. And then you're going to do integration by parts a second time on this integrand. That's going to be your u, and then of course this will be your dv. So now we let u equal cosine of the ln of 8x, and then du is going to equal, the derivative of the cosine is negative sine ln of 8x times derivative of ln 8x, which is 1 over x because the 8's cancel. And then you'll have your dx. Of course your dv is equal to dx, which means that v is just x. And so you should see that there's going to be a similar pattern happening here. We still have the 3 in front. We have x sine of ln of 8x minus. Okay, when we integrate this, you do uv, so that's going to be x cosine of ln of 8x. I'll put this, so this is, remember this is uv, or in this case we did vu, minus the integral of v du. The integral of v du, the x's cancel. This minus on the sign is going to make this positive, and then you're just going to have the sine of the ln of 8x and then the dx. And then this is where you should start kind of saying, oh wait a second, this looks like one of those problems where, look, remember I was starting 3 integral sine ln 8x dx. This is now equal to this entire expression. But what you should notice is that, hey, if I multiply through here, I'm going to see that 3 integral sine ln x 8x dx shows up again over here. So this is where you kind of get clever. You say, okay, well, my original question was 3 antiderivative sine of ln of 8x. And I found that to be equal to, I'm going to distribute the 3 through here, so onto each term. I found that to be equal to 3x times the sine of the ln of 8x minus 3x times the cosine of the ln of 8x, and then plus, well then 3 times the antiderivative of the sine of ln of 8x dx. Well, this is exactly the same animal as what we were asked for. So we have 2 of the same thing. So for example, if you wanted to call this thing, this entire thing, if you called that, say, A, then you see that whole thing over here with an A. And I have to be careful, don't I? I should have distributed this negative through right here to make this a minus. So since I have the A over here and I have minus the A over here, I see that 2A, where, remember, this whole thing is like your A, that's what you're looking for, is equal to 3x times the sine of ln 8x minus 3x times the cosine of ln 8x. And of course we should have a plus c from the integrand. Okay, and so how is it then, that's what 2a is equal to, but how is it that, what is just a equal to? Because we're looking for just what a is. Well, obviously if we just divide 3 by 2 here, we will get the final answer just dividing 3 by 2. And if and that should help you. Okay.